Okay, sure.
Yeah, today we are going to discuss about rack awareness.
Okay.
Once again, so I'm muting your side. Yeah, so rack awareness, like just imagine we'll be having two set of racks. Okay, so just for example, I'm having data node 1, data node 2, data node 3, data node 4, and I'll be having two set of racks, and each of these racks will be connected to one bus bar. It's a main switch where all the racks will be connected to each other. So the entire cluster will be connected like this in the switch type. Saiti, if you have any question, you can ping me. I'll unmute you. So data node 9. Data node 11. Okay. So this is how the data nodes are there. We have 8 data nodes each rack. I think total I have to get 16, right? Somewhere I missed data 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5. Okay. Okay, then I think this is the 1, 5. Okay, that's okay. Yep. So whenever I'm trying to store 100 MB of file, for example, hundred MB of file, as per the HDFS, these will be splitted into two blocks. Okay. Is splitted into two blocks. Okay, one is with 64 MB as a default block size. The other one will be the 36 MB. The rest of the block data will be in another block. So if I enable this rack awareness, okay, we have to manually configure this rack awareness feature when we are installing the Hadoop cluster. When we set up the Hadoop cluster, we have to manually enable this rack awareness. So something like we are explicitly mentioning that to the cluster Hadoop system, as all the data nodes will be stored or will be maintained in the terms of racks, will be there on racks. So it may understand, the Hadoop system may understand. So okay, fine, this cluster setup is configured based upon the rack. So all the data nodes will be placed on the racks. Okay, it will understand. Based upon that, it has own algorithm in order to make functionality or while storing the files in those data nodes. It has some methodology to store that files when we enable this rack awareness. Okay, fine. When we enable this rack awareness, whenever the client requests to store this 100 MB of file, it will be splitted internally into two blocks with the information given by the name node, 64 MB and 36 MB. As the name node also no, instruct the client. So okay, so and so data nodes having some space, you can go and store those data. So for example, let's understand like so data node 1 is free, you can store your data, client was instructed, so it will give it's the first primary copy to the data node 1. Okay, it will give the primary copy to the data node 1. So okay, fine, it has written the two blocks on this data node 1. Okay, and as we know, whenever any data node receives the primary copy from the client, it will then internally divide or share the other duplicate copy to some other data node. Okay, and that will be taken care by that will be instructed from name node, as we have to maintain 3 copies, as the replication factor is given as 3, so we have to maintain 3 set of copy. So can you please do that? It will be instructed by the name node. So data node will be giving the will be taken care of copying the data sequentially to the nearby data node if that is available, if it is having some free space. Okay, are you able to hear me, Saitya? Yeah. So as per the instruction, this data node 1 will give the second copy to the data node 2, as it is very near to the data node 1. And if in normal case, it will be given to the nearby data node 3 or 4 based upon that. But when we enable this rack awareness concept, it will give the third copy to the other rack which is near to us. Okay, let's assume this is rack 1. No, this, let's assume this is rack 3. Rack 2 is some other no, it's there. Okay, it's rack 3. Okay, so in rack 3 we'll be having data node 9, it's having some space, we can give the third copy. Oh, this is how the storage will be taken care whenever the rack awareness is feature is enabled. Okay, the first copy will be given to the data node 1 by the client. The client will take the data node will take care of the giving the it's is its responsibility to make 3 copies available on all other data nodes. Okay, because it has the primary copy, it has to share those primary copy to the data node which is having some free space. Okay, so so that reason it has given the second copy to data node 2. Based upon we have enabled the rack awareness features, so it's giving the third copy to the some data node which is there in other rack. Okay, why we are doing it like this? Okay, just assume like if this data node fails, okay, a client want to read the data, so it will go to the name node, and as it from the name node it will get the information like on rack 1 this data node 1 is having this data, can you go and directly read the data from data node 1. Okay, while accessing data node 1, no, it will goes through the network and connect to the rack 1 network. In rack 1 network, all these data nodes will be interconnected to each other. Okay, fine, it will try to read the data from data node 1, so it is failed. So immediately, without wasting the network time and all, it will immediately goes to the data node 2. As it is in the same rack, it's very easy to go switch to data node 2 for reading the data. Yeah, I'm coming to that point, Saitya.
Hi.
Yeah, I'll come to that point, Saitya.
Okay, yeah, sure.
Yeah, that is the client want to read the data. No, as per the instruction from the name node, information given to the client by the name node, it will come to the rack 1. In rack 1, in data node 1 will be having that data, so it will try to read. Due to some reason, this data node 1 got failed. Okay, so even though it has came through all over the network, okay, so data node 2 is very near to data node 1, we'll be having the same copy on data node 2 as well. Immediately it will go to data node 2 and it will read the data. Okay, So this is how it can able to read the data. So okay, fine. This is where it's working very fine. So what if this network cable got disconnected or due to some network traffic, this entire rack will become inaccessible. Okay, entire rack will become inaccessible if there is some network issue or a cable issue between the rack and the switch. Okay, network switch. So entire all these 1 to 8 data nodes will become inaccessible. If we have the third copy in the same rack, we will be losing the data, right? So that is the reason we always storing the third copy in some other rack in order to maintain high availability or high throughput. Okay, so that is the main advantage when we enable the rack awareness concept. So cluster will understand that if it is the data nodes have been placed into on the racks, so we have to store the data in this way. Okay, if the entire rack is inaccessible, will can able to access the data in some other rack. Okay, that is the concept. If we not enable this rack awareness, we will be having the third replication block with some other data node in the same rack, because no, it is always try to store the data which is near to the data nodes, the primary data node where we will have the primary copy. Okay, any questions, Saita, in this? Did you understand why we enable the rack awareness?
Yeah, I have a doubt if and the same doubt is repeating in me. And the second, I mean the third rack also enable the network access will all shut down, right?
Yes,
So what
yes.
will happen? Then the data will erase on data node 9 also, or some other place it will store.
No. So
Uh,
just understand, immediately
okay.
when the client accesses the data node 1, so
Okay.
data node 1 got failed. Okay, immediately client,
Okay.
this data node will be updated in the name node. It's inaccessible, it's having some problem. Okay,
Okay.
so then if that is the case, the data node 9, we have another block, right? It will try to replicate
Yeah.
this uh, oh sorry, it will try to replicate this data blocks to the some other data node on the same this rack.
Okay.
It will try to maintain the 3 replication factor.
Okay. It always try to back up the data
Yes,
in
yes,
any node.
correct. When
Nearest
entire, no,
one. Yeah,
whenever,
nearest one.
yes, whenever it is known that this rack 1 got failed, even though we have only one
Okay.
set of copy, it will try to replicate the third
Yeah.
copy in some other rack which is available.
It will automatically taken, or some other person will do
No.
that
It will be taken
thing.
care by the framework itself. That is the advantage in this HDFS.
Okay.
Okay.
Oh, okay.
Just
That's what. Okay. Yeah, I'm
we
glad.
have to explicitly enable this rack awareness.
Okay.
So if we enable this, no, physically, if the data nodes are placed in such a way like in these types of racks, so we have to explicitly mention
Okay.
like, so we have mentioned we have placed the data nodes in the rack system. So we take whenever we enable this feature, framework will take care of this kind of storage methodology.
Okay.
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 So always it will try to maintain the 3 replication factor, and it helps us to
Okay.
maintain the data will be in the high availability, high throughput. It can be accessible at any time by the client.
Okay. Got it.
Got
Thank.
it?
Yeah. Got it clearly. Thank you.
Yeah, thank you. So that's the one. And I think we have already went through this slide.
Yeah.
Okay. The same thing is this one. Okay. HDFS features file system namespace. Did you know what is file system namespace? It's the kind of metadata of the entire HDFS file system will
Okay.
be maintained in name node.
Okay.
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 So entire namespace will be maintained in one place, and the reference of those data, actual data, will be placed in one
Mm.
place. Like name node, we have the
Okay.
metadata information. Actual data will be there with
Okay.
the data nodes.
Okay.
Okay. So data
Okay.
replication by default it's 3. and the
Okay.
replica placement will be taken care, as I said, right? Replica, we always will try to maintain the 3 replication factor, and how this
Okay.
replica selection is taken care. If you enable this rack awareness concept, it will select
Okay.
the replica of the blocks. How we have
Yeah.
to select the replicas, the third copy, and all. How we are going to store, how we are going to manage the methodology of storing the replica. And the
Okay.
safe mode startup, it means like whenever we start the name node, it will start initially with the safe mode. If in
Okay.
safe mode, we cannot write any data to the metadata. We can read the data, we cannot write the data. It's the first time whenever we start any machine, it will be starting in safe mode.
Okay.
Okay, and the file system
So
metadata. Yeah, any question?
yeah, the safe one means only the reading the data, not writing. So
Yes.
we should keep the automatically the safe node will go, or we should keep the safe node.
No. It's framework one. Whenever we start the name node service first
Okay.
time.
Okay.
Okay, whenever it will be restarted, or when it's starting for first time, it will be in safe mode.
Okay.
After some time, the node
Okay.
will automatically come out of the safe mode. We can start writing the metadata information. We can
Okay.
start
This is
writing
an
the block.
advantage or
Not we, data nodes will start write the metadata information to name node.
okay. Okay. Got it.
Because data node is the only one who is going to give the information that can be updated on the name node.
Yeah.
Okay, whenever it is
Yeah.
started in safe mode, so data node cannot write any new information to the name node.
Okay.
Means it cannot update any new information or new data it got received. It cannot update those information to the metadata.
Okay.
Okay, the file system metadata. That's what the next point, file system metadata.
File system.
Metadata in the sense data about the data.
Data about the data. That's what
Like index in a page, index in a book, where the topic name and the reference to the page number will be given, right? In the same way,
yeah.
the data wherever it is located, the name node address, how
Okay.
many blocks it has, the file name, the directory path, all this information will be there with the name node, where we call it as a metadata.
Okay.
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 Yeah. So all this communication and all will be in terms of protocol, TCP/IP protocol.
Okay.
Okay, all this communication will be taken care of. All HDFS communication protocols are layered on top of a TCP/IP protocol. HDFS communication, in the sense communication
What
between
is my TCP?
it's
What is TCP and IP?
TCP in the sense like we call it as a transfer. I'm not sure about it. I know about it. I'm not able to recall that. IP
Okay.
means internet protocol. Okay. Intranet protocol, wherever
Okay.
we get the IP information of that system, which is connected in the network, right? The
Okay.
communication will be this called as TCP. No, transfer communication protocol.
Okay.
Something. The data transfer and all will be happen by this TCP.
Okay.
Okay, with this help of these through
So why we use
network,
this?
that the actual data transfer will be happen.
Okay.
Okay, so all HDFS communication, the client to name node and client to data node and the data node to name node. All these missions can be discussed. Can be can communicating each other, right? All this communication will be happening
Yeah.
over the network. So we call it as a TCP/IP protocol network, where the actual communication will be happening between these systems.
Okay. The
Okay.
communication between the systems, right?
I think some noise is coming from your end. No?
No, actually, my friend is going, so she came here. So she's going to the college. I said I will not come. I will come afterwards. So that's why I opened the door. Sorry.
Oh, okay. Then. So if it's getting late for you,
Yeah.
we can.
No, it's okay. No. It's okay because this is important, right? I have to manage the both things. That's why I told 11:30 is hard, but I can manage it.
Yeah. Okay. Then we can stop this.
Only today I'm having presentation. Every Monday I'm not having. Today I'm having one big presentation. So some
Okay. All the
competition.
best. All the best for your presentation. I think everything is getting recorded here.
Oh, because the college is coming end this time, so very busy.
Okay. So then,
Okay.
we'll start.
Sorry for the
Yeah,
disturbance.
it's okay. We'll go into the topic because everything is getting
Yeah.
recorded here.
Yeah. Oh, sorry.
Okay. So a client establishes a connection to a configurable TCP port on the name node. So name node will having some IP address. So client will
Yeah.
it will configure the connection to the name node, and it talks client protocol with the name node. Okay, it will establish a
Okay.
connection. The client machine which establish a
Yeah.
connection to the name node, where we this connection we call it as a client protocol.
Yeah.
Client protocol in the sense the communication between name node and the client.
Okay.
And the data node talk to the name node using data node protocol.
Okay.
Okay, the communication between data node to name node we call it as a data node protocol.
Come 1 second.
So RPC abstraction wraps both client protocol and data node protocol.
Okay.
So what do you know, this RPC will be having a secure tokens between these connection, these communication, because it always used to communicate, right? So every time, in order to remember every time, we will be configure those communication protocols, client protocol and data node protocol in this RPC configuration. Okay.
Okay.
Name node is nothing like it's simply a server, never initiates any request. So you
Okay.
have to make sure, we need to be it's very important point. Name node
Okay.
never initiate any request. It will just respond to the request.
Okay.
Let's make it clear. Name node will
Okay.
never initiate any request. It will just respond to the request from client or from data node.
Okay.
It will just respond to the request issued by the clients or data node. Okay.
Okay.
So this is how the communication protocols between on the HDFS.
Okay.
Yeah. So robustness. The primary objectives of HDFS is to store data reliably in the presence of failures. So all this intelligence, this replication of data, okay, always try to maintain the 3 replication, and automatically the blocks have been divided based upon the configured block. So balancing the cluster, all these kind of activity will be internally taken care by the framework that we called as a robustness. Artificial
Okay.
intelligence, it's a kind of intelligence systems. It will take care of everything. The failures which occurs in the network level or on the hardware level, whatever it is, it will always try to maintain the data availability anytime. Okay,
Okay.
100%.
It's a robot or something. Artificial intelligence means something related to the robotics,
No,
right?
just comparing to that, it's kind of it can able to recognize the failures and able to recover from it.
Okay.
So
Okay.
no human interaction is required, no interruption is required, or in this,
Okay.
it will automatically take care of the failures. It can able to recognize the failures,
Okay.
and it can able to recover from it.
Okay.
Recovering in the sense, not from recovering from the hardware failure and all. It will try to recover the data which is available in the failure nodes.
Okay.
Okay, it's always try to maintain the data availability.
Okay.
So there are there are important 3 common failures on the on the HDFS. One is data name node failure, and the other
Okay.
one is data node failure, and the third one is network partition, like in the failure over the network.
Okay.
Name node failure in the sense the service or system, the name node system goes down.
Yeah.
That we call it as a name
Yeah.
node failure. Data node in the sense data node system going down.
Okay.
Then network failures, and there is some network fluctuations or high traffic available in the network. That time we cannot able to access the data. So that is called network
Okay.
failure.
Yeah.
So how the data node failure will be detected? Based upon the heartbeat from the data node to the name node. Whenever
Okay.
we didn't receive any heartbeat from the data node, so it assumes that the data node is failed or dead. Okay, it will try to re-replicate the data which is there in the failed data node in some other data node which is having some space. Okay, it will always try to balance the cluster. So equally the space has been allocated and it is equally utilizing the space on the HDFS among all the data nodes.
Okay.
And also we have a capability to maintain the data. It always try to maintain the data integrity, in the sense data availability. So the final one
Okay.
is metadata disk failure. It will happen whenever the name node failed. If name node failed, we
Okay.
cannot access the metadata on from the name node, because name node itself got failed. If we are not able to access the metadata, it means the entire cluster is down. The entire HDFS has become inaccessible.
Okay.
So in this case, we have to maintain the secondary name node where we'll be taking this metadata information. We'll be having some checkpoint for every 60 minutes where we'll be taking the backup of this metadata.
Okay. This will also get backup, right?
Yeah. That can also be configured and will be taken backup. It's kind of checkpoint. Every 60 minutes once it will get, we'll be having one checkpoint and we'll be taking the backup.
Yeah.
So this is how the HDFS robustness.
Okay.
So how we can access the HDFS? So for
Okay.
HDFS, we'll be having one Java API for application to use, where we can browse the entire HDFS, like it's kind of web interface where we can browse the data directly.
Okay.
And Python access is also used in many applications. It's a kind of Python application which is also
Okay.
used to access the HDFS file system.
Okay.
C language wrapper for Java API is also available. So
Okay.
we can develop our own application for this Java API using C and all. It's on all different types of application we can develop on our own to access HDFS. And we'll be having
Okay.
HTTP browser can be used to browse the files of HDFS instance. And we will be having command line interface where we can where we call it as a file system shell. Okay,
Okay.
we'll be using some Linux commands integrated to Hadoop, where we call it as Hadoop commands. Through those commands we can access the entire file system. When we do you have any idea of using putty?
No.
Okay then. Okay, I will discuss one by one. Okay. Yeah, where will we will be using that putty to access the file system and all. Okay.
Okay. I don't have any idea about that.
So I'm not tracking the time. If you have your time gone, no, it's run away. Will
I will let you know if my time is completed.
okay.
After 12:30 is no problem. I already informed it to my group. I will come late. They will manage something. So it's okay.
I think it's not it. Okay then. So we'll discuss one more, part on HDFS, space reclamation. Okay,
What is it?
space reclamation. Reclamation. You able to see that?
Yeah, I can see it.
So reclaiming the space, which is when
Okay.
we delete some files on HDFS, how we will be reclaiming the space
Okay.
of that
Hmm.
which is held by that file which we have deleted. No,
Okay.
how to reclaim that
Okay.
space. So just this scenario talks about what happens when we delete a file on HDFS. Okay.
Okay.
Okay. When a file is
Yeah.
deleted by a client, okay, client will be requesting to delete
Okay.
some files on HDFS.
Okay.
So HDFS will do like internally, it will rename the file
Mm.
to a file to be the trash directory for a configurable amount of time. Now the first point is
Okay.
when we delete any file in Windows, when we delete any
Okay.
file, it will directly go to the recycle bin, right?
Yeah, it will go to the recycle.
Yeah.
But if we delete the shifted elements, it will not go, right?
Yeah. But in Linux environment and all, when we delete any file, it will directly go to the trash directory where we call, it's kind of recycle bin for that OS, Linux environment.
Yeah, it's a backup one, right?
Yeah, in the same way in Hadoop also, in HDFS also, we will be having one trash directory. So whenever we delete any file on HDFS, it will go to the trash directory.
Okay.
And the file will be available on the trash directory. We can configure the time period, or 1 hour or 3 hours or 5 hours or 24 hours. The file will be there in the trash directory. After that, it crosses that time, the file will be removed from the trash directory as well.
Oh, okay. We can't see again back.
Yes.
Right?
If you need any file, you need to reclaim that within the configurable amount of time. If it exceeds that, then the file will be permanently deleted from the trash directory as well.
There is any exact time limit is there
That
for that?
configure. That's what it's a configurable amount of time. It's up to us to configure. We maintain like 2 days or 3 days of time.
Okay.
No, up to that no, every 1 week we'll be having we'll be doing a balancer, that is scheduled. The balancer will take all this trash directory or unreferred data and all will be there in HDFS. It will clean up those data permanently. Okay, it will reclaim some space available, to use on HDFS. Okay.
Yeah, perfect.
Yeah. The client can request for an undelete in this allow time. We can undelete means we can reclaim that file. We can restore the file back to the HDFS in this allowed time, in this configurable amount of time.
Okay.
After the specified time, the file is deleted and the space is reclaimed. Okay, the space which is held by that file will get reclaimed after it got permanently deleted. If it's crossed that exceed time, if it exceeds the specified time.
Okay.
The file will be deleted and the space which is used by that file will reclaim back to the HDFS.
Okay.
When the replication factor is reduced, so okay, fine. This is one more scenario. Like we have by default 3, right? Replication factor.
Yeah.
What we can configure it as 2. Okay, I have configured it as 2, but in HDFS all the files having 3 copies. Okay. The name node select, it will just check, okay, we have access 1 copy for all the file. It will delete that and it will reclaim that information, reclaim that space back.
Oh, okay.
Because it always referring to that will be having some configurables, XML files where we'll be configuring these values. Okay, it always HDFS, the name node will always refer to that configuration files. Okay, if we change any value in that file, it will treat it as the final value. It always try to maintain the state where the configured value is met or not. Okay, it's always equal with matching with that configured value. Initially, when I start the install Hadoop cluster, we have configured as 3. Later, sometime after 1 week, I've changed it as 2. But the data which I stored before the changing this value from 3 to 2, all the files will be having 3 copies, right? So immediately when I change this value from 3 to 2, it will try to delete the excess copy on the HDFS. Okay. So next heartbeat transfer this information to the data node that clears the blocks for use. Okay, how this information will be given to the data node in the sense whenever we change the file, while immediately next communication between the name node and data node, it will try to say like we have excess copy for these blocks, you can delete this.
Oh, okay.
Okay. Any questions?
Yeah. No, actually, everything is.
Yeah, we have completed this data node HDFS important topics and all.
Okay.
I think if you have time,
so next.
It's over.
Yeah, we can go.
No, you can go.
No, you can cut with 10 minutes. It's okay, no problem. I'll manage.
So I'll just show you some set of commands.
Okay.
We have to learn Linux or Unix, some basic commands. It will be helpful for us.
Yeah.
So
I already researched about few topics in Hadoop. I went to the Hadoop website. The same. They told first introduction, then they will start like this. I'm also researching few things because I have to learn fast, right? So
I have some documents I'll share with you. So where we have a
yeah, you can
description
send me.
for each and every commands, how we can use that. Okay.
Yeah.
So I'll just.
Whenever I got free time, I can read about it.
Okay. So will be a. Do you know VMware mission? This is what the VMware mission. We have to install this.
Okay. Okay.
So tomorrow we'll discuss about the what are the cluster setups we have in Hadoop. What are the different
Okay.
ways the
Sure.
cluster can be configured? Okay, what are the configuration
Yeah.
files involved in this? That's and all some basic idea where we.
Actually, tomorrow.
Yes.
From tomorrow onward, we can start whatever you are flexible with in the time.
Okay.
Only Monday, Thursday, 11. I mean, for you, 9 p.m. is perfect. Other days, I'm okay with any other time.
Okay, fine. So yeah, this is what the terminal.
The software.
Yeah. This is what the terminal, the Linux.
Eclipse, I already installed.
Okay.
Because I'm taking Selenium classes also, right? And he told to install Eclipse.
Oh, okay. You're taking both Hadoop and Selenium.
Yeah, Selenium is the backup because that is easy technology, right? I can keep that backup.
Oh, okay. This is also easy, not much.
That's
No. In US,
this is
if you're good with the basics and all, then it
yeah.
will be very. 1 second.
Yeah, I took artificial intelligence, mobile application.